Okay, so everything will be recorded for later use. So let me try to share my screen. Desktop. Share. Okay, I'm just sharing the screen. So basically today I will just finish what I started last week, a week ago. It was a slide set of few topics, exceptions, IO, and we still miss reflections and annotations. So I just basically will show you up what I have not done a week ago. And I think this will be it for today. So lecture should not be long, should not take the whole 1.5 hours. It will take less. But I think this is good because this is the last week you have to prepare until the deadline for the first task. And some of you have not yet done this. I actually have went through your tasks already and have checked it up. Everything seems to be fine. Most of you have got the maximum score. So for most of you, it's already done, but part of you have not yet done. So I don't want to go into the design patterns, concurrency and persistence, and functional programming. These 4 topics are mostly related to the tasks number 2 and 3. So let us finish reflections and annotations. So next week we will start fresh from talking about the design patterns. It should take a couple of weeks as well. Concurrency should take a week or 2 as well, maybe 1 week. Persistence is fast, and functional programming. So we have plenty of time left, so no hurry in showing up with topics. So basically that's why I will start and show up what we have actually missed a week ago. Okay. So basically, last week we talked about the exceptions. I'm just basically running through the topics that I covered before. So basically, we talked about exceptions. We have checked exceptions and a couple of exceptions which are not checked ones. The difference actually in requirement of throwing and accepting them. So you must know this already. Techniques for handling them, so basically catching up and throwing up in the stack, tribe resources, usages should not be abused, and so on. So exceptions, I think, are okay. These are just the normal classes that you can use for your applications. And I think in task 1, you have already had to implement a few exceptions of your own, and some of them were checked exceptions. At least one was a runtime exception. So I've got a few questions from you that you didn't know how to actually handle this exception. So yeah, it was a runtime exception. So I guess everything's clear now. Okay, about the streams, it was another topic which we covered a week ago. So it was a stream IO. These are the objects that actually are associated with the direction towards the stream or from the stream, so output and input stream, respectively. So basically, we have byte streams and character streams, which are basically decode values into the UTF encoding, and from encoding basically depends on direction. Then we had a notion of buffered streams where we can read data into the buffers, scanning. This is just a buffered reader of some sort, when formatting, command line. Okay, these are side things. Data streams, these are streams for serialization of the primitive values plus strings, package, and visualization. We looked at visualization, serializations of objects. So we have an object input and object output streams, which act as a mean for serializing and deserializing objects. So basically, there are ways in doing this. Overriding methods for the default serialization and deserialization, basically, yeah. Okay, so basically I showed you examples about this. Some of them work, some did not, because examples were put into the notebook. And notebook, Jupyter kernel actually has its culprits, so everything of the classes that are being created, they are isolated and they have a special naming. That's why sometimes it did not work, but I think you've got an idea about the serialization and deserialization already. Okay, so another option in working with I/O, with input-output, was presented for you as so-called new I/O. So basically, this is a notion of channels and buffers, in contrast to the previous one, streams. So we have a notion of channel. This is asynchronous read and write object. So you don't have to predefine the direction, right, from the initialization of an object. And there's a notion of buffers, which are basically act as an intermediate for reading and writing. And these are the differences. New I/O has a very handy set of API objects for working with file system. And yeah, we looked into this. Actually, it was introduced in Java 7. Before Java 7 was very, very badly written utilities for working with file systems. So since then, it is very, very nice actually to work with a file system in Java environment. Okay, so here we are. We just approached the another topic which we did not touch last week. It is the topic on reflections. So basically, reflections are the modern technique in the various programming environments and programming languages and wherever, which are basically have an ability of the technology to reflect its state. So basically, reflection is basically a possibility when you are running an application to get the information about the application itself, about the structure, objects, names, modifiers, etc. So basically, get information about the program that you are running. So basically, reflection is used in most of the languages and most of the technologies these days. And the primary usage for the reflection is actually to extend features of language. So if, for instance, you do not know some kind of a structure, an object, or object features before running the actual application, so you can extend it runtime. You can add something on top of what already have been done, what already you have built up while developing an application. So for instance, this is very clearly can be visible in the task number 2, because in task number 2, the last test, what it does, it generates classes runtime. So basically, when you are running the last test, I think test number 5 maybe, you basically will see that what it does, it generates a class, it generates a field, associated methods as well, and basically various annotations. So you beforehand, before running an application, you just don't know what is the structure. So this is very handy because you should develop an application in the generic way, so it should adapt to the structure of a class dynamically. So that is why, while constructing the second task, while working on a second task, at some point you have to start using reflections. So basically start to reading information about the object that you have just received. So you will know what fields are there, what methods are there, how to access them dynamically, and so on. So this is for the extensibility of the program. The other use case would be the various browsers and IDEs. And this is obvious because when you are programming something and you have an application running, you want to see what's inside. So for this purpose, you need to be able to read about the structure of the running program. And the last use case is basically the possibility for the debuggers and various test tools to, again, read about the structure and not only read about the structure and what's happening, but to inject various utilities. For instance, we use in Java many different techniques that inject various code lines. Basically, mostly in the shape of proxies that measure execution times in various methods, that measure how many times the method was called, and so on. So by using reflection, you can inject the code runtime into the methods and classes. So you basically can measure various properties while running. Okay, so obviously this is not only a handy tool, it has some drawbacks. So the drawbacks basically are related to the performance overhead, because once you start using reflections, you will be going into the some other area of the programming. So if you would use too much reflection, right, too many code lines that would use a reflection, you would be getting penalized by the reduced performance, of course. So for the normal application, you should not be referring to reflection. These are so-called hacky things. In order to use them, you have to have a very good reason. Security restrictions. So obviously, if you, for instance, have declared a method or a field that it is a private one, it should not be read by anything outside. By using reflection, you can change that. You can basically mark a field or a method that it is not private anymore, so you can read it back or change it. So this is the exposure of internal. So basically, this is the last point that I wanted to say. Okay, so all the things that we've mentioned as good things for the object-oriented programming can be overcome by the reflection. Okay, so it's good and evil at the same time. Okay, so most of the classical way in accessing information about the running class is basically starts from the class object, right? So class type. So basically you can access it from either instance or the class name. So for instance, foo. This is the first line, right? Foo actually is a string, right? This is an instance of a string. So .get class. This is a method of an object. So basically accessing the type instance, right, of the string class is actually by calling .get class. So this is instance, and .get class is a method of the object class, right? So this is super type. For all the classes actually has this method. So once you do .get class, this class instance C is actually has all the definitions about the string class. Okay, so boolean.class, this is an access to the primitive value. So .class, this is something like a field. This is the special notation for the primitive. So primitive.class, you get immediately the guy. Okay, so if you want to access by the name, by the string, so you can do this class.forName. So class has a static method class, is a class, right? So it has a static method for name. So you just dump in the name of a class that you of a type that you want to get, and you basically get it. There are various abbreviations. For instance, a bracket and D, right? So the only option that's possible here, and this is a shortcut for the array of doubles, right? So basically you can access like that. These are all the hacky things, right? So this is an array of strings and so on. So basically, yep, primitive type wrappers can access double dot type and type get as well. So there are various methods how we can get a handle of the class. So basically, once you got it, you can access methods, fields, etc. for this specific class that you want to refer to. Okay, and basically class has various methods that return other classes, right? So you can you can navigate over from the class you started from. So for instance, dot get superclass, basically you can access to the superclass class, dot get classes, any associated classes like nested classes, etc. That are enclosed into the current class can be accessed like this, declared, declaring, enclosing classes, and so on. So various types of classes are possible to access from within the class. Okay, so basically examining the class. So once you got the handle to the class, you can access various modifiers for the class. So this class instance dot get modifiers, you get is it a public, abstract, and so on. So basically you can look up various properties, modifiers for the class. Then any type parameters for the generics, right? If there are some type parameters, type variables coming from the generics, you can basically access them like that. Generic interfaces, if it implements any interfaces, right? So basically interface, list of interfaces. Get superclass, which is just a super, get various annotations. If this class is annotated by some annotations, so you can basically get an access for the annotations as well. Okay, so basically getting fields, the list of fields from the class. So it's basically get fields. This is an access to the public fields, so members, which are directly declared in the class, but is a public inherited members. So all the public inherited members are accessible here as well. Private members are not accessible by directly going into the get fields, right? So basically, in order to access private members, any fields or methods, whatever, you have to refer to the declared fields, because declared fields returns everything what was actually declared within the class that you're working with. So members as well as private guys, right? Everybody are being returned. Okay. Get field, no. Yes, no. I think it should be yes, yes, something like that. I think this is an error, because it should reflect more or less the same thing. Get declared field, I think it should reflect as well, because this is the same thing. Okay, it was changed at some point. Okay, somehow I see that my slides have been changed in a not normal way, so I don't know. Maybe at some point I have shared the editable version of the slides, and then they were modified by some not so nice guy. Okay, so I should be looking into this more carefully. Okay, so this is so basically once you get a handle on a class, then you can go and get the declared method. So basically by trying to get a method, so obviously methods are different by the names, so basically providing a name. So by the name you can access it, but of course a few methods can have the same name but might differ in the signature, right? So the whole signature of a method is actually composed by the name plus parameters. So basically, this is how you provide the list of parameters in the right order, right? So this from this class, we want to get the declared method, the method which is actually declared in this class itself, not the inherited one. So you provide the name and provide the types of parameters. So basically, there should exist a method declared in this C class by the name iClass with the name and which has a parameter. First one string, another one is a Boolean. To get an array of all the methods, so basically method array you can get like that without too much trouble. Okay, so basically this is how you get methods and this is how you get fields. Okay, this is how you get fields. Okay, constructors. Basically, constructors has similar access like the methods are. So basically, you get the class again and start from the class. You get a constructor of the class. And if constructor has a set of parameters, right? So basically, you provide types for these parameters, right? So here you just get the whole list of constructors that are available for the class. So once you have the constructor, right? So you can execute the constructor, and you can execute the constructor. You can call it, right? So C. This is a constructor. Okay, this has to be CO new instance, and this is a string. Since this constructor, this CO constructor, had one argument, string argument as a parameter to be inputted in, so here it should be CO, right? New instance. Let me fix that. Okay. So this need to be CO, right? CO new instance. Okay. So basically, once you've got a variable with a constructor, you can basically do that. This is C is not correct as well. Okay, I have to fix these things at some point. Okay, so this was a way to access reflections, to access information about the classes right from the class type, but this can be fixed. Not fixed, but you can use an alternative way. This is by using the so-called method handler. Method handler is different in a way that you can specify the type system without having already existing set of types. So basically, these types can be declared without accessing the class and so on. So you can, for instance, specify the method, right? Method, this is a method that we specify without having the actual class, and then we can use it. So basically, this is a handy way if you want to specify your type system, your own type system, and then you just basically apply on the existing virtual machine. I think we will have some kind of an example which reflects this. Okay, now let's take a look into the example for the reflections. Let's run this. Okay, so I have a few utility methods. This is examine methods. So what it does, it receives an array of methods, right? And it loops each method and basically prints. So a list, so basically this is a method. It gets the name from the method, each of them, right? And then list parameters, first or not, because it just basically first or not, it just wants to close it, I think. Yeah, it just basically close it. So basically, yeah, it loops over the parameters and prints them out, right? So nothing special. This is just a helper utility method to print out the method somehow. Okay. This is for examining constructors. So basically, again, it receives an array of constructors and it loops constructors. So basically, if constructor prints just like the method, just like with the method the same way. Okay, just so we can compile it. So now here is this quite extensive method, helper method again, where we have a class. So basically here instance of the class. So basically type definition is being passed. Once we have it, we basically print it out. So we tell if it has a superclass. So basically we print a superclass as a name. Then we get any nested included classes. If they are available about it, we print them out, just the name, not recursively. We could, of course, call for each C the same examine class, but it would be just too much. Okay, then get declared classes, the classes that are available and that are private classes declared inside this enclosing class. Declaring, enclosing, modifiers. These are basically classes that could enclose the current class. So basically, we just want to know if any class is actually enclosing the current one. So if we would be calling examine for the declared class, it should have printed the enclosing class, the one which was called before. Okay, then it prints modifiers is abstract, so we can check the list of modifiers. If abstract is in a list of modifiers, is final, is public, is static. Okay, then any type parameters for the generic class, generic interfaces, if we are to be implemented at this class, annotations if present, fields are listed here by basically listing a type and the name. Declared fields are listed here. So methods, declared methods concerned. So basically, other utility classes are basically shown up here. So again, running that guy. Okay, so basically this was my string class. As you can see, this is a string instance. We .get class, we just called get class. So we took an instance of the class type, which is basically associated with a string, and we printed it out. So what it says that this is a class java.lang.string. This is basically a package, and this is the name for the type. Superclass is an object, right? Any declared classes within that one, string case insensitive comparator. Yes, it has some kind of a class declared within. Any declaring no and enclosing no. Modifiers, it has a 17 modifiers, so you can imagine this a lot. Abstract no, final true, public true, static false, generic interfaces, serializable. It is serializable, comparable, so it can be compared with another string. And this is interface of character sequence. So it can be used as a character sequence after all, right? So fields, declared fields, basically declared fields that are private fields. This is a public field, which is case insensitive order. This is something like a constant. Okay, then it has lots of methods, various virtual methods listed here, right? There are a lot, bunch of constructors. These are all the ways that you can use to actually construct the class, the string, right? Okay, there are some methods which are private ones, not visible actually from outside. Okay, so we can do the same thing with Boolean, right? So this is a Boolean. This is a primitive thing, I think, yeah. So that's why it's very tiny. It doesn't have anything to say about it, but it basically lists some kind of info. And since this is a primitive thing, we have to know it somehow. I don't know how. If you know it, just write me down, or we can find it. What kind of is class actually? This is an optional. Optional, right? This is Java util optional as an example. Okay, it has some declared fields inside. This is a declared field. You see the actual value is a primitive field, which is being stored, right, as an object. It has a type variable t, so this is a generic optional, right? So again, this is a generic. We looked into this example, so this is implementation of optional by Java util, so this is coming from API, so it's a generic thing, right? It's stored with t is actually stored as a object, which I mentioned before. Okay, so this is a double array. So it's again slightly different definition than we saw before. This is a primitive stuff array. This is the string array. Okay, this is an array of strings. So that's an idea. Okay, double type, so double primitive type wrapper. This is what it says. Okay, so what we have here is we have a definition of our own. So we just have declare the class testus, which has e and f with type parameters, right? And it has a constructor where e is being passed in, right? So this is the class we have just specified. This is a shell and the number of cell, I think, something like that. This is the specifics for the notebook, so we just not look into this. But the superclass and object, okay. So basically, we have two type variables, e and f, which we did. We have two declared fields, private fields, e and f. Right? So these are things coming from an object, right? Including the get class and the constructor. This is the constructor, which takes object, right? We declared that it takes e. Okay. Just a string. Test a string, new testus, wrong number of type arguments required 2. What's wrong here? Let's check. Type argument. So we need to input something like this. Input, the first one string, the second one is integer. So this is the first one e. The second one is integer. Okay, so cannot find symbol test input. Integer, okay. Sure. Okay, now it's okay. I just basically mistyped it. Okay, so just the same thing, because it just, while using this guy, and we just have a different access. Here we accessed from the type.class. Here we get from instance get class, right? So basically different access from the type itself as a field, and here is the access from the method. Okay, so here we have a few examples that manipulate objects. So basically, object.class get method to string. So basically, we get a method to string, right? So from the type object, we just got a method to string, right? So what we can do, this is a method, right? So basically, if we do this like that, the string, this is a method, right? This is a method. Dot class. This is not a class. This is okay. No, this is a class. String. Okay, get class. Get class. So this class of this instance class is a method. It comes from Java lang reflect method, right? So we have a handler for the method. Okay, so what basically we can do, we take this method and we invoke on some other object, right? On some object. So basically, this is how we invoke the method, right? So basically what we do, we have a handler and we run it on some kind of object. So for instance, the string dot invoke, right, on something like this is my string, right? This is my string. Okay, so it basically wrote down, it just basically executed what toString would return. So this was exactly the same thing as, for instance, string s equals that guy, and then I would just print s dot toString. This is just exactly the same thing, right? Okay, what I can do, I can just basically take this up. Take this up. So we have a string specified. Now I basically pass it here. So it basically prints, and this prints. This is by using the reflection, right? So this is reflection way, right? And this is the usual way of executing a method. Okay, so this is how we take the constructor. Again, we've seen this quite a bit, right? So basically C, now C get class is actually a constructor, Java lang reflect constructor. So this is a different type, right? So it was a method, now it is a constructor. So now in order to construct this new type, we just basically call it accepts one parameter, a string. So we basically can call c.get new instance, c new instance, right? So now s is basically was constructed. Okay, so now let's try to get length. This is a length, right? Length method. So basically we got a handle len.get class, right? This is a method. This is a method, right? Method type. We just got it. Now we just invoke an s on this labutis. So this is 7, length 7. 1, 2, 3, 4, 5, 6, 7, right? 7. Now, okay, so 7. Now we can access as well a hash field, right? So basically string is immutable. Immutable means that it's, just to remind you, that it constructs object right in the constructor and does not change the state. So basically what it does, the string actually is being, the hash is being stored as the field from within, from the, in the object itself. It is very handy because once you construct this hash, you don't need to repeat it again, right? You just basically do it once. So basically, let's try to look into the hash. So basically, s dot hash code, right? So basically, let's print out the hash code. So this is the hash code. So basically, what we do, we take the field h as the hash field, which is declared in the string. Let's make it accessible so we can access it, and let's take it, right? So as you can see, it is just exactly the same as the hash code, right? And this is a hash code, right? Okay, accessible. Okay. Can we change it since we have changed it to accessible, right? S dot, so string hash equals 1, 2, 3, 4, 5, 6 as a private access. So basically we have got access to the field, but we can't change it right away. Let's try to change it like this. Set integer, right? We can set integer 1, 2, 3, 4, 5. Right. So for the classes, right? Something like this. Okay. So now let's try to execute it. Hash code. So see, we just have changed the hash code. What I did, just for your convenience, I have taken method, not a method, I have taken the field hash, right? Field hash is the cached hash code for the string. So let's move up and see in the string, it should be visible, right? Get declared field hash, right? So it is basically a hash code which is cached for the string, right? And basically once it needs to return via hash code, right? Via hash code, this hashing basically returns a field. It does not compute anymore. It just does it once. And this is very handy because it doesn't need to compute. So for the immutable object. Okay, so what I did, I just have changed this field modifier to the accessible one. So basically it's not private anymore. I can access it, I can modify it, right? And what I did, I just basically have set in different value, right? And so it returns a different value for me, right? So basically it was changed. So this is the example how you can actually manipulate objects, manipulate state, which was not meant to be manipulated by using the reflection. Okay, this is another example for the method handles, which I showed you before and said that this is an alternative way, a new way of coding, because this way you can set up, you can create the type system without actually using the right objects. So let's take a look. So what we do, we just basically import a few types. We have point class defined, right? And we have method handles lookup for ourselves defined as a lookup object, right? So we find setters. We just find a setter in the type point, right, for x of integer type. So this is obviously, it is here. We have not declared it explicitly, but we expect that setter is there, right? So basically, if I would print right now point.x, right, it just says it's 0, right? The same way it would be point.y equal point.y, right? It would say 0 as well. So these are default values for all the integers, right? So what I do, I get method handles set x and set y, and basically invoke these with some additional values, right? These are setters. Now I can find getters for these types, right? So, and basically can get the values. So what is done, this looks up a getter in point type and basically invokes it, executes it. And the same thing with y 1 and 2. So basically values has changed. So we can take a look in the usual way, right? So basically point x, it's 15, point y, it is 10. So basically by looking up these methods, we just basically have been able to change. Okay, so as you can see, okay, so these method handles are very similar to the methods in the previous reflection method, right? But here is a different way, so we can basically define, not by looking up, we can define, for instance, the method type. This is a method type definition, and this type basically returns integer, right? It returns integer and accepts a couple of integers as parameters. So this method is an abstract one. It does not have association to anything with the existing type system, right? So we can define this method as a method abstract. We can have a library of methods, etc. So once we need to execute it, then we basically attach it by using the lookup to some type, right? So math class, static method, add exact, this is the name. This method did not have any name defined, it just had an abstract signature. So basically we're looking up for the method with the name add abstract, which add exact, which has the signature which was defined here, disassociated with the method, right? So basically, and it finds. Okay, so now basically what we can do, we can basically execute on x and y. X and y, are we declared anywhere? I don't know. Let's take a look. Okay, we are. So basically x and y were, are declared here. So basically 15 and 10. So this was added exactly, it was added, two integers were added exactly, right? Now let's try to add something like the integer max value, right? Max value. So it says that integer overflow. This is an example that math add exact is looking into the possibility of overflow. So if you want to add, to do additions or subtractions or whatever and want to avoid the overflow situation, which we talked about during the primitive values topic, primitive type topic, so you can use math dot for instance, subtract exact method, right? Which would, for integer minimum value, right? Subtract 12, right? It says that integer overflow. So basically, we have hit the maximum, the minimum possible value to store, right? If you did not, it just would return normally as it would return without anything else. Okay, so this way, this method handle is an alternative way, but what you can do, you can define, this is just a very simple, very primitive example that you can define the methods without being associated with the existing type system. Okay, so this was reflection. I think you've got an idea. Now we can move on and do some more slides when it comes for annotations. So annotations basically is a different construct of a program that basically is not a part of a program itself. It has no direct effect on the operations. So basically you do not declare any kind of operation or specify the structures, but what you do, you basically provide some additional information for the AA compiler. There are annotations that are used by the compiler, for instance, for error detection, suppressing warnings, deprecation, etc., etc. Or you can use these annotations for whatever reasons at the compilation time or the deployment time. For instance, some software tools are using annotations in order to generate code, handle various serialized formats like XML, databases, etc. Once we will be dealing with the serialization into the databases, so basically you will see that annotations are used a lot. This is the task number 3. And at runtime, so basically if you need some additional information about the data structures, about the types, so basically you can use this runtime. And task 2 is actually you have to check for the field that have a certain annotation assigned. Okay, so basically these are the example of various annotations. So we can see that class is being annotated with equals and hash code annotation. This is a specific annotation provided by the Lombok package library. And what it does, it during the compilation, it runs, the package runs annotation processor, and it modifies by using the reflection. It basically modifies this class by injecting equals and hash code. methods. So after injecting it, it actually obeys these attributes, like call super true. So basically on equals, it will call a super class with paged handler in order to assess if it is true or not, as well with a hash code. Exclude row, so basically it tells that you should be excluding this field in calculation in equals and hash code condition. Okay, so getter and setter is obviously we generate getter and setter methods for the row, getter and setter method for the column. This is a constructor, and it is annotated with inject. This means that this object, lob handler, this class, can be actually handled by some controlled environment with the dependency injection. We will be talking about this later in design partner session, but this says that some controlled environment can create these instances of lob handlers for you, and basically what you have to provide is the query. So actually this one you have to provide because it's annotated by assisted. Otherwise it would be injected for you, taken from somewhere. Okay, so this override you know already what it means. Okay, so there are a bunch of actually annotations that are possible to be put everywhere in a code. So as you can see, you can put annotations on a block, right, on receivers. Generic type annotations are possible, like not null, not empty, read only, etc., etc. So there are various types of annotations. But one of the key points is to understand that you should not be using them too much, because this is quite complicated code, one thing. Another thing, that handling of these annotations is not explicitly specified in the Java API. They are mostly used by the certain packages. Even though non-null, not empty, read-only annotations are specified in API, but the usage need to be taken care by the application, right? So, okay, it should not be used too much, these things, right? So, for instance, type tests, etc., etc. So, critical throw clauses, okay. Okay, so even though annotations have become quite complicated in Java, we have some annotations that are, I think, exists from day one when annotations appeared in Java. So these annotations are associated with the compiler. So basically, we tell something for the compiler how to handle certain situations. For instance, deprecated annotation, it says that this element, which is marked with annotation, is to be removed later on. So you should not be using that. So for instance, when you're using some kind of a library package and it has a method or class which is annotated with deprecated, then you will use it, compiler will throw a warning, and some configurations of applications basically do not allow that. So in big programming houses, sometimes they require to not use the deprecated methods or classes. Sometimes it's very picky. So basically, if you want to inform the programmers who would be using your library that we should not rely on a certain method, so you basically mark it as being deprecated and to be removed in the future. Override, you know already. This is very handy to mark that this method is being is to override the super type method. Suppress warnings. So if there are some warnings that are being thrown from within the method or basically within a block or a class, you can basically tell that warnings from this block should not be thrown, right? So basically this is how you can basically still use a deprecated method by basically suppressing warnings. Okay. Sometimes this code is being scanned for suppressions, and this might not be allowed as well in the compilation and configurations. Okay, these were annotations for the compiler, right? So what you can basically do, you can create your own annotations. So annotations can be created just like normal classes in a file, which is basically which file name follows the name of annotation. So basically, this is how you specify it. You have put @sign, then interface, and then the name. And these are attributes that you're about to define for the annotations like info, right? And there are various additional annotations on top of annotation declaration that basically specify how to deal with this annotation, right? So basically, you can specify a target. So you specify on what structure object, on what language object this annotation should be put at, right? So for instance, here we specify that this annotation named test is meant for the methods only. So whenever somebody would try to put this annotation on top of a class, it would throw in an error, right, during the compilation, because this annotation is meant for the methods. You can stack these targets here. As well, retention is basically what retention policy, what persistence policies to keep for the annotation, because annotation is not essential for the program. So annotations are not being kept in many cases during the runtime and being thrown away during the compilation, right? So for instance, if you would put the retention policy as to compile, after compilation, this annotation would not be available in runtime. And this would mean that test annotation is meant for the compile time only. So this is this one is said to follow the runtime retention policy. This means that it should be kept in the .class file during the runtime, so it will be available for reading via reflections. Okay, so this is the usage of this test annotation, so nothing special. You have a class and you have a method foo, which is basically annotated with test annotation. You will meet the custom created annotation in task 2. So, and you will have to find out by using the reflection fields which are annotated with some kind of annotation. And you will have to look up for the attribute name, because the attribute name is actually what will be used for the search manager. Okay, so later on, I think the next week I will explain more about task 2, because I just want to give you guys some more time in order to finish up with the task 1. Okay, so basically that's it for the annotations. And what I just wanted to mention, I think this is one of the last slides, that we have in Java, we have a notion of Java beans, and the bean is not the coffee itself, but this is a reusable software component, basically a class that is very typical for Java. It has to be public. In most cases, it has to be serializable because it might be used in storages, in flushing into the database, etc. But the typical component, Java Bean component, is featured by being a public class, by having a default constructor, because it is handled by somehow of a mechanism, so it needs to be able to create without assigning any fields, and it has to have getters and setters for all the fields available. So once you have this class, you can tell that this is a normal bean, right? This is a bean, this is beans, and these are Java beans, these are modal classes, etc. So these are the typical classes to hold some kind of information for your application. Okay. And there are a bunch of utilities that work with Java Beans. So basically coming from Java Beans package from the SDK of Java, and Patch Commons has a package and so on. There are various utilities to work with Beans because they are very, very usual in Java environment. Okay, this is just a slide about the packages, namespaces, organization. Don't know what to tell about this. This is from Java 8. So this is my last slide. Basically, we looked into the last, I would say, slide set about the usual things in Java. This includes exceptions, IOs, serializations, reflections, annotation, and bins. From now on, we will start looking into the specifics. So I hope that you've got a good understanding about the generic Java. And now we will start looking into the specific topics, which includes design patterns, right? We will look into the design patterns, concurrency, so multi-threaded execution, persistent, this is more coming from the enterprise Java, and functional programming. I don't know if it is in the right order, in this order, but I think we will be looking in more or less this order because design patterns are needed for task 2. Maybe I will move functional programming to the before concurrency and persistence, because functional programming I've been asked already to explain. So, but design patterns should go first anyways. Okay, so that's it for today, guys. Somehow I was able to extend this to 1 hour. So I'm capable in doing that. So I think you've got an idea about these things, and we just can meet in a week if you don't have any questions. If you have questions, you can basically stay after and ask me, or you can post into the chat box. Okay, so that's it for today's. Stopping the recording.